the first question, I would like to talk about the difference between techniques washing and extraction. Washing and extraction are both able to separate compounds based on their solubility and their ability to form different immiscible layers. One layer is the aqueous layer and one layer is the organic layer. The organic layer contains our desired compound, and the aqueous layer is the layer containing our contamination and impurities. These two processes are pretty similar, but they're just used for different purposes. Extraction dissolves the desired compound and leaves the contamination and impurities behind, while washing is able to clean the desired compound by dissolving the contamination and impurities and leaving our desired compound behind. For performing these techniques, firstly, we need to secure a ring clamp by connecting it to a ring stand, and then placing our separatory funnel on top of it. We need to make sure that our stopcock is closed before adding our solution to the funnel. In washing, we firstly need to pick a proper solvent that can dissolve the impurities but not our desired compound. Then we can add our second solvent to the solution and close the separatory funnel by a glass stopper and then shake it side to side. By doing so, the second solvent can dissolve our contamination and leave our desired compound behind. Our desired compound will remain on top, and our contamination will remain at the end of the funnel. By opening the stopcock, we're able to remove the contamination layer, aqueous layer, and isolate our organic layer in the funnel. At the end of this experiment, we can add a new compound called drying agent in order to remove any extra water from the solution, because this is so important in this experiment, because water can also be considered as a contamination and make our desired compound impure. Extraction procedure is pretty much the same. We just need to pick a proper solvent that can fully dissolve the desired compound, not the contamination. We can close by adding the second solvent. We can close the funnel with stopcock, shake it side to side again, and by doing so, the second solvent is able to dissolve our desired compound and leave the contamination layer behind. Then by opening the stopcock, we are able to remove the organic layer, our desired compound layer, and isolate the contamination layer inside the funnel. At the end, we can add our drying agent again to the solution to remove any extra water from the desired solvent. In question 2, I was assigned mixture compound number 2 because my last name started with M. Therefore, my compound number 1 was anthracene, my compound number 2 was piperidine, and compound number 3 was oxalic acid. Based on my research, I found out that compound 2 and 3 are both soluble in water in room temperature, while compound number 1 is not, because it is nonpolar and it is poorly soluble in water in the room temperature. As a result, I can add water to the mixture as a solvent. It can dissolve compound number 2 and 3, but compound number 1 will form a precipitate in the mixture, and by performing vacuum or suction filtration, I'm able to remove the isolated compound number 1 from the mixture, and also have an aqueous solution of compound number 2, compound number 3, and water. So at this point of our experiment, we need to perform a vacuum or suction filtration. For doing so, we need to set up our suction filtration apparatus. We need to put a sidearm flask on top of the counter, place a rubber sleeve on top of it to ensure the tight seal, and also we need to place a Buchner funnel on the rubber sleeve and place a filtration purpur on top of it. And we can start our vacuum filtration by attaching the vacuum pump to the flask and turn on the vacuum. For doing so, after a few minutes, we will have our compound number 1 stay on top of the filtration paper in the form of solid, and we'll have the mixture of compound number 2, compound number 3, and water in our flask. Okay, and now we can use a tool called rotary evaporator, or ROTEV as a short form, in order to dry out the water as a solvent inside our mixture and have compound 2 and compound 3 mixture isolated as a solid. This machine uses heat and vacuum to vaporize a water and leave the solid mixture of compound 2 and 3 dried out. In order to do so, we need to pour our solution to a round bottom flask and attach it to a bump flask on the ROTEV and secure it with kick clips. The bump flask traps the solution that bumps and does not allow it to enter our rotary unit. The flask will constantly be rotated and heated in order to remove the solvent and have the solid isolated. Vacuum is also used in this tool by attaching a vacuum pump to the flask. The purpose for using vacuum is to decrease the pressure inside the flask, and as a result decreasing the boiling point, so the water or any other solvent will be vaporized faster. And the solvent will enter a condenser that has a cool unit, and it can turn into a liquid again. Therefore, the liquid solvent will be collected in a separate flask, and our dry mixture of compound number 2 and compound number 3 will remain in our round bottom flask. By looking at the literature references in the internet, I found out that compound number 2 is soluble in ether, acetone, and chloroform, while compound 3 is insoluble in all these 3 compounds. As a result, I can choose one of these solvents, for example, ether, as a solvent, and add it to our mixture. By doing so, compound number 2 will be dissolved in the solvent, in the ether, but compound number 3 will form precipitate as a solid inside our mixture. By doing the exact same method as we use for compound number 1, like vacuum filtration, we are able to isolate compound number 3 inside the Buchner funnel and have a mixture of compound number 2 and our ether inside the flask. Therefore, we need to perform the rotary evaporator again in order to remove the ether from the solution and have isolated solid compound number 2. By doing so, we have separated each solid in different steps of this reaction. At first, we removed compound number 1 by adding water. Then we removed compound number 3 by adding ether as a solvent, and at the end we are left with a isolated solid compound number 2. Alright, in the third question, I'm going to explain the procedure of experiment organic synthesis. In this experiment, we're looking forward to produce 2-butoxynaphthalene from using 2-naphthol and examining the purity of the compound we produced at the end of the procedure. At first, we need to add 3 pellets of NaOH, which is a white solid, 5 milliliters of 95% ethanol, 0.5 grams of 2-naphthol, and stir it in a round bottom flask. And then in this stage, we will have like a greenish brownish colored mixture, and then we can add a condenser on top of the flask and start boiling the compound. By doing so, the 2-naphthol will react with NaOH, and the proton transfers from 2-naphthol to the hydroxide ion and produces 2-naphthoxide, which is the conjugate base of 2-naphthol, and it also produces water. Condenser in this experiment prevents the solution from drying out, and also ethanol has a role as a solvent in these experiments. We can continue the boiling for about 15 minutes until the solids are completely dissolved into the solution, and at this point we will have like a brownish colored liquid. And at this point of the reaction, we need to remove the condenser for temporarily and add about 0.5 milliliters of iodobutane using a digital pipette. Place the condenser again and start boiling the mixture again for about 1 to 1.5 hours. By doing so, 1 iodobutane will react with 2 naphtha oxide and produce 2 butoxynaphthalene and iodine ion. And it occurs when the solution is boiling. After boiling, we will have like a reddish orangish colored mixture, and we need to save a few drops of this mixture for performing TLC experiment at the end. At this point, we need to pour our solution into a beaker containing 10 grams of ice and swirl the mixture. At this point, we will have like a creamy mixture in color. When the ice is dissolving, we can also add some ice cold water to the flask and get the remaining liquid from inside of it and add it to our beaker. When the ice is melting, we can see small solids are forming like on the side of our beaker, which means that precipitation is occurring. These solids are like off-white color. And at this point we can conclude that our 2-butoxynaphthalene is not soluble in water. As we see, it's precipitating in water, but it was soluble in ethanol because we were able to proceed the experiment in ethanol. And when the ice is completely melted, we need to do a vacuum or suction filtration in order to isolate the 2-butoxynaphthalene that we have produced and separate it from all the remaining solvents. I also would like to mention that our 2-butoxynaphthalene is an off-white colored solid, and at this point we need to perform a TLC experiment. For doing so, we need to have a solution containing ethyl acetate and hexane with a proportion of 3:1 as our element, and we also need to make 3 dots at the bottom of our TLC plate. In the first dot from the left, we can add our reactant, which is 2-naphthol, and on the right dot, we need to place our product, which is 2-butoxynaphthalene, and in the middle dot, we need to add both of them, a few drops of both of them, so it would be a mixture of both reactant and product. When placing the TLC inside our eluent, we see the liquid rising up on the TLC. It will also move the compound on each dot to the top, and if you wait for a few minutes and remove the TLC plate from our eluent, we can observe the TLC. We can observe our TLC plate and see where each point stands. If by looking at the right dot, if we just see just one dot, it means that our compound is pure and also no reactant is inside of it. And by comparing the right dot and the middle dot with the left dot, we can compare where reactant stands and where product stands in this TLC experiment. I would also like to talk about some properties of 2-butoxynaphthalene. As I mentioned, it is an off-white solid and its molecular formula is C14H16O. It is a non-polar compound. Its molecular weight is 200.28 gram per mole. Its melting point is between 31 to 33 degrees Celsius. Its boiling point is about 315.3 degrees Celsius. And as I mentioned, it is soluble in ethanol. It is not soluble in water because it is not polar. And it can also dissolve in non-polar organic solvents. We can also see its IR spectroscopy results. There are some peak wavelengths between 1500 and 1600, which belongs to the benzene aromatic ring. And we can also see some peaks at 1019.87 and 1066.06. These peaks belong to ether functional group inside the 2-butoxynaphthalene compound. Alright, and last but not least, I would like to, in question number 4, I would like to talk about the techniques we have learned in this course for identifying the characteristics and purifying our compounds. One of the first techniques we have learned in this course is recrystallization. Recrystallization is technique used for purifying an impure compound using an appropriate solvent. An appropriate solvent is a solvent that dissolves our compound very well in high temperatures, but slightly dissolves it at room temperature. For doing so, we need to add a desired compound to the chosen solvent while heating, and then when it's completely dissolved, we need to remove it and stop the heating, and then let it cool at the room temperature, and then move it to an ice bath solution and wait for it to recrystallize. And after a while, we can see some small crystals forming in our solution. These crystals are the purified version of our solid compound. The second technique I would like to mention is melting point determination. It helps us to determine the purity of our solid compound, and which is achieved at the end of our recrystallization experiment. It is worth mentioning that contaminated compounds have depressed and broader range of melting point. It can also help us to confirm the identity of our produced compound by comparing the experimental results of melting point to our literature references on the internet. The third technique I would like to mention is thin layer chromatography, or TLC as a short form. It helps us to determine the identity of components of a solution by comparing the RF values, because each compound has a special RF values for itself, and by knowing the RF value, we can identify what item it is, what component it is, and as a result, when we observe multiple spots in our TLC result, we can conclude that our solution is not consisting only one component, but it consists multiple of them, because it has different spots with different RF values. It can also helps us to determine if our final product is pure or not. By seeing multiple spots in the result with different RF values, we can conclude that our compound is not pure and it contains some contamination and impurities inside of it. We can also see the progress of our reaction by performing TLC experiment. For example, when we see the appearance of a reactant, it means that our reaction wasn't completely progressed, or if we just see the products in our result, it means that all the reactants were used and products are produced. As a result, the reaction is completely proceed. TLC is a very inexpensive way to also determine the polarity of compounds, because our components move on the TLC plate based on their polarity. The ones that can have a strong intermolecular forces with the TLC plate will stay at the bottom of our TLC plate, and the ones who are not really attracted to the plate will move up with the eluate. As a result, we can also know if how polar or non-polar our components are. Therefore, it's a really good tool to use in our chemistry laboratory. The fourth technique I would like to talk about is distillation. It is a useful method for purifying a liquid and extracting it from a solution. It has two different methods to use. One is simple distillation and one is fractional distillation. Simple distillation is used for components with boiling points differing with more than 100 degrees Celsius, and the fractional distillation is used for components with boiling points differing with less than 100 degrees Celsius. In this course, we weren't required to use any filtration distillation method. Alright, and the fifth method I would like to mention is infrared radiation spectroscopy, or IR spectroscopy. It is a useful method for examining the purity of a certain compound. It can also be used for identifying the unknown components of a solution. IR measures the light that was transmitted through a sample and the absorption of light by a compound. IR is also a really easy and useful way to identify the presence of certain functional groups in a compound. The sixth technique that we used in our labs was washing and extraction. By using these methods, we are able to purify our desired compound from contamination and impurities. These techniques are able to separate our components based on their solubility and their ability to form two separate immiscible layers. They are pretty similar in procedure, but they're just used for different reasons. Extraction is able to pull our desired compound from one liquid phase to another phase, while washing is used for cleaning our compound from contamination by moving our contamination and impurities from one liquid phase to another. We can perform these techniques by adding a chosen solvent to our solution in order to dissolve either our desired compound or our contaminations and impurities. One of the new techniques and materials that we used in our lab was drying agents. Drying agents are able to remove water, which is considered as a contamination in our solution. By adding the drying agents, water will be extracted from our solution, and it will be pured afterwards. Because the existence of water in our solution means that our component is not exactly pure and it is contaminated. So by using drying agents, we are able to purify our component. Okay, the eighth technique that we used is gas chromatography. It helps us to analyze the liquid organic compound and examining the purity and identifying the compound in a liquid solution. It is similar to 2LC. It has two phases, the stationary phase and the mobile phase. It can also help us to identify the polarity of components inside a solution by observing the results. The last technique and the ninth technique that we used in our labs was rotary evaporator, or RODEV as the short form. It is used to remove the solvent compound from a liquid solution, and it helps us to dry out and purify our solid compounds by removing the solvent. This machine uses heat and vacuum in order to remove the solvent from the solution. It uses vacuum to decrease the pressure inside the flask, and it also helps to decrease the boiling point, and our solvent will boil at a lower temperature, and it boils faster, and it will be removed from the solution and left us with dry, solid, pure compound.